Graph each function. All right, so in example A, we have f of x is equal to 2 times x minus 1 to the fourth power plus 3. And you can see that on the left here, I've graphed actually f of x is equal x to the fourth power, because this function A is basically a transformation of that original function x to the fourth. So they basically multiplied it by 2. They've shifted the vertex around a little bit, but other than that, it's basically the same drawing. It's just a question of where it moves to, right? So let's start by talking about where that vertex will go. So if you look at what's happening here, we're going to have this minus 1 in the parenthesis moving it to the right 1 unit. Remember, whatever happens inside the parentheses, it's kind of opposite of what you might think. So when you see a negative 1, you might think go to the left, but then remember that it's opposite when it's in the parentheses. So we'll actually go to the right 1 unit. So we're actually going to move over 1 unit to the right. So that's going to basically move the graph kind of over here, right? But then, of course, we're actually going to be also adding 3 to it, right? Which means the graph is actually going to move up 1, 2, 3 units to over here. And so your new graph will look something like this, right? Now, the only thing we have to do, though, is to figure out what effect the 2 has. The 2 is going to basically vertically stretch it, right? It's going to rise even faster than it normally would. But in order to get a decent enough drawing of it, we basically already have it done. But all we can do from here is basically plot extra points to confirm where the rest of the graph goes. I think we only need to plot 2 points, really, that will really help us. Those 2 points I want to plot will actually just be 1 step away from the x-coordinate of the vertex to the right and 1 step to the left. So I'm going to try to plot what does x equals to 0 look like, and what will x equals to 2 look like. Those are points that are exactly 1 step away from the x-coordinate of the vertex. So if I use 0, that's 1 step to the left of where the x-coordinate of the vertex is located. So what will y or f of x become? Well, let's plug in 0. If I put 0 in there, I'll end up having 2 times 0 minus 1 to the fourth power plus 3. And you can see that that's 2 times negative 1 to the fourth power plus 3. And that's the same then as 2 times 1 plus 3, or in other words, 5. So we'll get 5 here for this one. What's nice about this graph is that the other value on the other side has to be the same thing, as long as it's the same distance away from the vertex on the x-axis. So by going to the right, out to 2, we've gone 1 step further than the x-coordinate of the vertex. So basically, we should also get 5 here. We can confirm that by placing 2 in here, so we'll end up having 2 times 2 minus 1, which of course is just 1 to the fourth power plus 3, does indeed give you 5. So the 2 points we have are 0, 5. So 0, 1, 2, 3, 4, 5 might be up here. And then we have 2, 5. So that's 2, 5, that's here. And that's basically what our graph will look like. So remember to kind of make it flat, because the x to the fourth is kind of flat there at the base, right? And then it sort of skyrockets up from there. Now that's basically our graph. All right, let's do the same thing for the other one over here. So they've written the other one in a slightly different format. Normally we'd have that 2 at the end of the graph here in g of x. So normally it would be minus parentheses x minus 3 to the fifth plus 2. That's okay, don't let that confuse you. In fact, I'm just going to cross that out here and just put plus 2 here, right? It's the same thing, correct? And the reason why I want to do that is because I want to show that this graph is very similar to x to the fifth. It's just a transformation of that. So first thing that happens when you make it negative, what happens to a graph like this? Well, when you make it negative, the graph will virtually just do this, right? It's just going to open the opposite way. It's going to reflect across the x-axis, right? So it's basically just flipping over the x-axis. All right, so that's good. The next thing we'll notice is that they've taken the vertex and they've moved it up 2 units and moved it to the right 3 units. Remember, inside the parenthesis, it goes in the opposite direction you'd think. So we're going to move this central point over 3 units and then up 2 units. So it's actually going to end up being over here then. So the graph should look something like that, right? All right, to confirm that, all we have to do is plot again a couple of points, and we'll choose those strategic points that are just what? 1 step away from the vertex in either direction, right? So we'll move over to x equals 2 for one of the points, right? So x is equal to 2. And then we'll see what happens to g of x in that case. And then we're going to look at what happens if x is equal to 4, right? And see what happens to g of x in that case. Okay, so let's plug in x equals 2 into the function. So we'd have what? Negative 2 minus 3 to the fifth plus 2, which is the same as saying negative 1 to the fifth plus 2. Negative 1 to the 5th is just -1, and if you multiply by a negative in front of that, you'll get +1, and 1 plus 2 gives you 3. So we'll end up having 2, 3 as our point. So if we plot that, it'll be 1, 2, and then up 3, so about here. And we do the same for the other side, but we put 4 in this time. So we'll have negative parentheses 4 minus 3 to the 5th power plus 2, which will end up giving you negative 1 to the 5th power plus 2. And that'll end up being negative 1, because 1 to the 5th power is just 1, plus 2 ends up giving you just 1 as your value. So that means we're going to go out to 4, but only go up 1 for the y-axis. So out to 4 and then up 1, and we end up with that value there. All right, so let's try to connect these dots in a way that makes it look like the snake graph. So we kind of have this dropping down here, and then maybe it rotates through there, and there we have it. Okay, so that's basically our graph then in red, and that's essentially how to transform the graphs x to the 4th and x to the 5th.